Good day ka-CRT. For this video, we will solve this problem under integral calculus, finding the volume of the solid generated. Find the volume of the solid generated by revolving about the x-axis. The area bounded by y equals x squared, x equals 9, and x-axis. So first, let us plot this drawing or the given values. So for y equals x squared, this is a parabola with center at 0, 0. And it opens upward. Next is x equals 9. So let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. X equals 9 is a vertical line. Then, x-axis. So this is the x-axis. This is the line x equals 9, and this is the given curve. So the portion or the area bounded by the given curves will revolve about the x-axis. So to illustrate that, this is our x-axis and it will revolve about the x-axis. So we will find the volume generated by that condition. So first, let us indicate again the intersections. So this is at 0, 0, and this is we already have x here, which is 9. Then to determine the y coordinate, let us use the given curve. If x is 9, y is 81. So with this illustration, to find the volume, again, we can use either horizontal strip or vertical strip. First, let us use vertical strip. So let me redraw again the drawing. This is the bounded area. And if we are going to use horizontal or vertical strip, and this strip will revolve about the x-axis here, we can illustrate the solid that can be generated by this scenario. So imagine this strip revolving about the x-axis. This is the generated figure. Yeah. So this is the generated figure. This is the strip. Okay? So by the way, the sides of the strip, let us represent the sides of the strip. This shorter side is dx. This is always true for vertical strip. The longer side of the strip is y. So this is the proper representation of the sides of the strip. Let us relate this in our generated solid. Why? It seems this is the radius of the strip, or y is the radius of the generated solid. So this is y. dx, it is equivalent to this portion of the generated solid. If we are going to analyze this generated solid, it looks like a cylindrical object with very small height. This is the height of this cylindrical object, and this is the radius of this cylindrical object. The volume of cylindrical figure is base times height. In this case, our base is circular, and the circular base has an area of pi radius squared. It so happens the radius here is y. So this is the base, pi radius squared. Then the height is dx. Okay, so this is dx. Therefore, the limit should be in terms of x. 0 to 9. Okay, so let us now include substitution because we are integrating in terms of x. So this y squared should be in terms of x. Okay, so this is now our integration. Pi y is equivalent to x squared. Then there is another power here, power raised to 2. Therefore, this is x raised to 4 dx. Limits from 0 to 9. So, use your calculator to solve this solution. Answer here is 37,101.58 cubic units. So this is the volume using vertical strip. Okay, so let us now solve the volume using the horizontal strip. So let us illustrate the horizontal strip. This is our horizontal strip. Okay, this shorter side is dy. This is equivalent to 9. This is x. Therefore, the length of the strip or the longer side of the strip is 9 minus x. The distance of this strip with respect to the x-axis is y. Then, our strip will revolve about the x-axis. So, imagine a strip, this strip, revolving about the x-axis. This will generate a solid figure as illustrated here. Okay, so this is the generated solid. This looks like a cylindrical shape with hollow inside. So to be able to get the volume of this figure, let me illustrate this as using this paper. So using this paper, okay, this is the generated figure. Then we are going to stretch this or expand this, and it will give a rectangular shape or a parallelopipe volume or solid. So let me draw the generated or the expanded drawing. So this will become okay. So it will yield to this solid with length. Let's say this is the length, this is the width, and this is the height. So to get the volume of this figure with length with height, this is simply length times width times height. But with respect to the strip, h is the 9 minus x value. Width is the dy value. And y will represent the radius, and if you expand the circumference or this side, when you expand this, it is equivalent to the circumference. So meaning this is equivalent to circumference, which is 2 pi of the radius, which is y. So therefore, our volume solution is length with height. So we will just multiply these parameters or values. So let me arrange that. Therefore, the integral of 2 pi y for this side times 9 minus x for this side and dy. So since this is in dy, our limit is in terms of y, which is from 0 to 81. 0 to 81. And x here should be replaced in terms of y. So x is equivalent to the square root of y. So our solution now is 2 pi y, 9 minus square root of y, and dy. Limits from 0 to 81. Now use your calculator. Okay, enter this solution, but take note, instead of y, use x in your calculator, because our calculator, this is our calculator, the Casio 570 ES Plus or the 991 version. The default integration is dx. So put x here in your calculator. Okay? This will give a value of 37,101.58 cubic units. So this is the solution for this problem using vertical strip and horizontal strip. Thank you for listening. Please like and subscribe to our YouTube channel. God bless.